Uh, Good morning, everyone. Warm welcome to all of you. On behalf of Mechanical Engineering and Bytes, I would like to welcome Dr. Devarajan, Head of Advanced Manufacturing and Production Engineering at TVS Motors. We are eagerly waiting for his very interesting talk and very relevant to mechanical engineering students. We welcome you, sir.
Thank you very much. Thank you.
Also would like to welcome Honorable Vice Chancellor, Dayanand Sagar University, Dr. KNB Murthy, who is also chairperson for Bytes. We welcome you, sir.
Thank you, sir. Thank you.
On behalf of Department of Mechanical Engineering, I'd like to welcome Professor Arvind Srinivasan. He is our mechanical engineering professor also for today's guest lecture, sir. So I think Arvind, sir, yeah, nice to see you, sir.
Yeah, nice to see you, Dr. Vinayak.
Nice to
Yes, sir.
nice to see you, Arvind. Yeah.
Oh, thank you, Dr. Devarajan.
Yeah.
Nice to have accepted this invite.
Yeah. Thank you. Thank you.
I'd like to welcome all the HODs and HODs of DSCE, DSATM, and faculty colleagues of Dayanand Sagar institutional groups, and all the students from all the three campuses. Now I request Professor Arvind Srinivas to initiate the talk with some introductory remarks. Sir, over to you, sir.
Thank you. Thank you, Dr. Vinayak.
Yes, sir.
Dr. Devarajan, it's a pleasure to have interactions with you earlier in the BCICI Management Committee when we spoke. And I'm very glad that you have accepted this invite again. And we are very glad to have you here. And it's a privilege to have the experience and the wisdom of so many years of yours in the automobile industry with the fraternity of Bytes. And thanks to Dayanand Sagar College for hosting this event. Wonderful, Dr. Devarajan, and I hope your association continues by being an industry person, such a busy man with the TVS Motors, managing to take them out and spend an hour with us here, and subsequently too. Thank you, sir.
Thank you. Thank you very much. Thank you. Thank you. It's always a pleasure. Yeah.
Over to you, sir, Dr. Vinayak.
Yeah.
Like, very interesting that I had met Dr. Devarajan and a host of others in the management committee about 2 weeks back or so at Bangalore. And I understand that he lives in Hosur, which is not very far away from the electronics.
I live in Bangalore, but I travel every day from Bangalore to Hosur.
Oh, okay. So then I think Dayanand Sagar College University School of Engineering, where Dr. Vinayak Hemadri heads the mechanical department, is probably on the way.
Yes, sir. I told, sir.
Yeah, you mentioned that. Yeah, also you already shared the.
So it is a privilege, sir, to listen to you without much.
I will share my screen.
Yeah. Yes, sir. Please, sir. Please.
Is my screen visible?
Visible, sir. Please go to presentation mode, sir, so that.
Yeah. Is it visible now?
Perfect. Yes, sir. It is visible.
Okay. First of all, good morning to every one of you. And thank you very much for Dayanand Sagar for giving me an opportunity, and Arvind, whom we met 2 weeks back in BCIC. My name is Devarajan. I'm with TVS Motor from the past 35 years. And the topic which I'm going to talk today will be interested for the students, because I feel the students are the key engineers who join our company. So there has been a changing situation in the Indian automobile industry. And I will particularly talk about automobile industry, though it is applicable for many other industries. And definitely the topic which will help us is what will be the impact of this on education and how we should be geared up to understand the changing situation in the industry. So this is my topic. Okay, so I'll try to make it short and slow, so that any question you have, you can always interact, and we can always take the questions at the end of the meeting also, or in that in the same context. So the main
excuse me, sir. Typically, the questions are taken at the end, with your permission.
No, no problem. No problem. No
so
problem.
Generally, we don't want to give a interruption in the thought process, and towards the end,
excellent,
Dr. Vinayak or one of the moderators, they will pose questions through the students and the faculty, and then they will.
Yeah, that will be very good. That will be very good. I think we can have a So this topic is slightly broader. So I will have an overview today, so that I like to give you overall picture of the need for manufacturing, what are the shifts in manufacturing happening, what are the advances in materials. I'll try to so what a change of materials, machines, and methods, and towards the change in management also, and what new skill sets are required for the institution and interface. So I like to bring in the joining between industry and the institution, because I strongly believe the raw material for us in terms of the machines, methods, main thing is the engineers who join us. So that's the reason why we are very keen to work along with the institution to enhance their syllabus and enhance that how people can be industry ready when they join a company. So this is my overall topic. So main thing for manufacturing, if everyone has a 1 minute, I'll try to put my pointer. So the main thing for manufacturing, as all of you know, is creation of products, which is used for sale and used for many areas of processes are happening. And that range of human activities is commonly applied, converting the raw material to the finished goods. In automobile industry, especially in two-wheeler industry, you have every part of mechanical engineering which you have learned, from metallurgy to machining to welding to press shop to the heat treatment, conversion of raw materials. So normally in TVS Motor, we are not little bit more of Atmanirbhar. We always say, okay, what happens to Jal, Agni, Vayu, Prithvi, Akash? How are we converting? Are we giving back to the society? Are we keeping the environment clean in terms of the assets, in terms of the workplace? So I always take very strong view with my engineers on five basic elements of which will impact the factory. Very, very important, because finally we say, hey, we are giving back to society. We are trying to have energy efficient processes. We are trying to, in our factory, we make it a point that 100% of water is recycled inside the plant. We are water positive. That is, water we give out will be more than water we take in. And we are something like 80-85% solar energy, green energies inside our factory. So very important as a part of engineers, as a part of our management itself, we talk about all the things from the basic design of the process, design of the product. So why it is important? Because manufacturing involves prosperity of human civilization. All of us are growing because mobility is a need of the nation. Okay, mobility is life in our company, because if you don't have mobility today, we are nowhere. In US, they say if you don't have a license, you can't go anywhere. If you don't have a vehicle license, you can't travel anywhere, and it'll be very difficult to survive. So I always believe in men, material, and welfare. So how to reduce the natural resources, how to improve our human efforts and reduction of human efforts in terms of automation will give you MMW, that is in terms of the efficient utilization of men, material, and welfare. So in manufacturing, don't think manufacturing as only change of raw material to finished goods. We are trying to use the nature's forces. We are trying to bring in the prosperity of human civilization and the growth of the nation. So in terms of growth of the nation, manufacturing contributes at least 30% in terms, or automobile industry contributes 30% of the manufacturing sector itself. So the market size is higher. The sector in terms of the automobile industry, pharmaceuticals, chemicals, manufacturing or mechanical engineering or mechatronics is applicable to all these industries. Though I may talk about automobile industry today, but every area, mechanical is a very, very key area, and mechatronics is a very key area. So in terms of significant contribution to GDP, if you talk about $6 trillion economy in 2025, so the major contribution will be on the manufacturing sector. And definitely Make in India, Skill India, manufacturing policy, the new education policy, I think is all are helping us to make the growth of India. So one point here I like to mention is every area, the basic engineering is a must for us to concentrate on. So then the challenges happening in the industry. Automobile sector is a backbone in the economic growth of the country. Backbone means it is the mobility of the nation is automobile industry. Okay, and India leads in increasing the rate of production. I think India is number 1 in terms of the two-wheeler industry, India number 2 in terms of the four-wheeler industry and the tractor and other areas of this thing. But what's happening is there's a change in the environment. We want to make it cleaner. We shifted from BS4 to BS6, shifted from there's no BS5. The government took a lot of initiative and said, all industries change over to BS6. BS6 is 1/10 or 1/15 the environmental emission of BS4. And it came up very suddenly in 2020. Today, we're talking about EV, how we can have hybrid, how you can have, like they're saying in California, the air taken in by the automobiles and air given, the exhaust given out by the automobiles should be cleaner than the air taken in. That is the area in which we are also working very closely. And we are saying how we can ensure that as a population, we can be clean in our vehicles. This happens, the Indian share of automobile industry in GDP is growing, maybe 12%, maybe 13% in the coming year. And it is in the growth pattern. So we are in a fantastic time today in terms of the growth of GDP and in terms of the global automobile volume production increase and automobile industry being the backbone and bringing the best to the customer. All of us are customer. You are a customer for us in terms of two-wheeler, in terms of three-wheeler, all of us are customer. So, in our company, I always believe that who is the first customer? The person who buys our vehicle is a customer. But I've changed it saying that the person who manufactures inside a factory, operator, is a customer. Because we engineers design a process where operator operates. We are able to ensure the ergonomics is okay, the flow is okay, the inventory is kept down, the lean production is taken into place, the 5 years is in order. So how will we ensure our first customer, operator, is happy? Similarly, engineers are our customer. Are we able to give them, guide them well so that they will flourish? They will be able to bring in new ideas into practice. These are the areas where we are changing the same management philosophy and work towards helping the operator, helping the engineer, helping the customer to buy a product. So these are the changes and the future trends in the industry. Okay, so coming back to our growth, which I talked in manufacturing. Manufacturing helps in all the areas in terms of the automobile industry. Today, the growth is happening even in aerospace industry because the type of machining we are trying to do, the importance given to the tolerances, definitely India will grow in terms of the automobile aerospace industries. Similarly, in terms of the electronic industry. Today, we have a problem in manufacturing because of availability of ICs. Our EV production is just started and we are just making something like 5,000 a month, whereas the demand is more than 3 to 4 months. So we are trying to say how India is supporting to make electronic industry, factory to make ICs, factory to make chips. These are the areas in manufacturing is growing. Today, maybe seen as labor intensive. But what happens is with all our ingenuity, how can you make low cost automation? How can you make lean manufacturing? These are my favorite topics. So how we can bring in manufacturing improvement in all the areas will cause the economic growth. So if I say manufacturing is a core of economic industry, it may not be mistaken. So we have to see that how we as manufacturing engineers make the ergonomics better, make the lean better, make the 5 years better, make the automation better. I'll talk about this much more in my next areas. So one thing happening is all of us are customers. So what do we need? We need very quick response time, higher value added product. In two-wheeler industry, the demand for the products having all the features of four-wheeler industry is demanded in two-wheeler industry at the two-wheeler cost. Correct? All of us demand this. I need a best vehicle. I need 100 kilometers per liter, like that. So longer, durable, and reliable products. Okay. Hence, it's important that we design our product to take care of the durability and ensure that the value add to the product. See, we have got everything on mobile today. And we are trying to say how much of these features can be built into a dashboard of our two-wheeler. And you can see Apache, you can see our Scooty, and you can see our all our scooters where N-Torque, which will give you the electronics at your hands. At the same time, we are trying to say how we can be eco-friendly in terms of the global warming, emission, which I talked about, EV talking about, and miniaturization, because lean is a key area. Lightweighting is a key area. I'll talk about it a little bit later in my topic. These are the shifts happening in the manufacturing. Okay. So we should always understand, you put yourself as a customer's shoes and say that, hey, I need a high value added product with me. I need a low cost product with me, durable. The thing, and make in India should be the make the best in the world, and which is economically possible. And everything is possible today, because in TVS Motor, we are working with BMW. We make BMW two-wheelers for the world in India, designed and manufactured in TVS Motor Hosur. So it is a possible of Atmanirbhar that we are able to make our own product, design for the world, and we are able to export something like 65 countries all over the thing. And now, especially Africa, Bangladesh, many countries, and for BMW products in around the world itself. So value add is very important topic, which all of us should understand and keep in mind, whether we are talking about a product, we're talking about the service, or we're talking about anything which will touch the customer. So who is a customer? And what is happening then, earlier, now, and future? I'd like to take a few words into it. And earlier, the quality was in QVC was in percentages. It's okay, acceptable. Now we're changing to parts per million. The future will be zero defect. Zero means zero. There cannot be anything which can be passed on to the customer. Similarly, earlier it was price was profit plus cost plus profit. Now, if you talk to any auto industry, every year, what is the year-on-year reduction? And now future will be the perceived value. We as a customer or a supplier, can we bring value to the OEMs? That is the future. Earlier, it was a monthly delivery, managed end of the month, okay. Now, no, on-time delivery. On-time, online customize. You can even order the vehicle in your cell phone. So the QCD, the quality cost delivery, is changing towards zero defect, and in terms of online and customized product. Okay, we can even order Apache to what we need in terms of the color, in terms of suspension, in terms of the position, in terms of seat. We can order as per what we need, and you'll get the product. Like that, you're trying to make towards the future. Similarly, in terms of machine tools, what's happening? All of our mechanical, so I took machine tools. I'm a very favorite of industry engineering and mechanical engineering. So earlier it was on SPMs. It went to flexible machines. Today, quality is very important. How you can ensure that we can have the quality built into a single setup. How to ensure that quality control is changed to process capability. That means to say how consistent is the product, whether it is a CPK 3 or 4 or continuously on improvement in terms of the process capability, centrality of dimensions, and ensure zero defects. Batch production is changing over to agility and variety. So this is the change which is happening because of what? Because we need to give value added product to the customer, I mentioned earlier. So that's why it is changing. And are we ready to take care of these changes is a thing that we should, as I proceed further, I'll tell you what are the actions we are taking. Similarly, in terms of the tooling, fixtures, it has changed from simple HSS carbide tools to carbide and diamond. Now it is becoming integrated tooling. Intelligent fixtures, you can change the component based on the barcode and the fixtures can accommodate it. That's the way we are trying to work in the fixtures. And how are we able to capture data on the machining area, on the tolerances area? Because why? We are talking about the process capability for the consistency of a product. So the attribute gauges have gone to as a variable, and now today online data capturing. Why it is important is the speed. Second is transparency, and you're able to take action based on the data. So hence it is changing over a period of time, and this is only an overall view what's happening in a simple way, which I try to mention. Similarly, in terms of industry revolution happening, every one of you know in terms of the industry 1.0, in terms of the mechanical production, that this leads to the industry 1.0, change towards the mass production. Especially Ford manufacturing came up saying that if you can have any color, so long as it's black, that is the industry 2.0. And in terms of the electronics, PLCs, and towards the industry 4.0. This industry revolution has created a manufacturing revolution. In what? In manufacturing revolution today is in the data. We in our factory today, all the systems are interrelated. All the machines are connected. All the fixtures are connected. All the operators are connected to who is operating, who is doing the delivery. Why it is important is any changes happening in the field or any problem coming in the field, we are able to trace back to the shift, to the person, to the material, to the supplier is a must. So that's why I'm calling it revolution. Is it necessary? I feel it is a must, because as customer, we can say, hey, my vehicle is not giving the required feature that what I'm asked for. So today customers are very well knowledgeable. Believe me, the customer, like all of us, know more about the vehicle than our manufacturers themselves, because you have the best in terms of the Google, in terms of the products, in terms of the best all over the world. You know what's happening in Sweden. Why can't you get in India faster? So it's very important that the revolution is happening in automobile industry. I hope I linked up to the from the requirement of the product on the value addition to the customer, and in terms of the changes happening in revolution, and in terms of the industry 4.0, which is the key. This leads to digital. In terms of Internet of Things, one minute, I'll try to. In terms of the artificial intelligence and deep learning, all of things. See, what's happening in our industry is becoming more and more mechatronics, more and more IT oriented, because many things are data driven. So how to have a better deep understanding of robotics, automation, machine learning. This importance is because of the improvement of productivity, which increases the output. Similarly, in terms of the flexibility, these are the words I'm telling you, everyone should be on their mind. Flexibility, agility, growth oriented in what we are doing, how to be more competitive. As a manufacturing engineers, other mechanical engineers, we should know that we should be competitive. Otherwise, we cannot survive. So in terms of productivity, main thing is competitiveness. Okay. And in terms of digital transformation, we are trying to talk about people to people, in terms of people to machine, and in terms of business. Today's engineers are more and more lucky because industry is growing and all their ideas can be put into practice in industry. So I think all of you are in a very, very fantastic time period of wherein you are able to apply many things to the industry. Sorry. So basically, I talk about digital transformation, but as a factory is concerned, as industry is concerned, we are looking at maximum on cost reduction. Though I talked about digital transparency, finally, we are all in business. So we have to ensure there's a cost reduction and ensure that the sales of increase in the new product, because we have to survive in the market. So what are the value drivers for this? In terms of time to market, in terms of the sales, in terms of the quality, by digital, we are able to improve the quality level and reduce the cost of poor quality more than 20%, improving the productivity, asset utilization, data transfer, data availability of the assets, and in terms of the automation. And so, though we are talking from transparency, improvement, finally, we are down to business, saying that how we can reduce the cost, how you can improve the time to the market. So each one is a big topic. So I just wanted to mention here, and we can talk about labor productivity in terms of the people, how to improve the skill sets, how to improve the automation in asset utilization, and how to bring in the new product development, what are the stages of new product development, and how to improve the capability of quality in terms of CPK, and how to ensure that the quality is built into the process. And all the things is managed today by a change on digital transformation. Okay, so this is the basic on which I like to take it further. We are talking about new things now, Internet of Things, advanced automation, industrial analytics, so that we have data, calling it the smart manufacturing technologies, and cloud, keeping in cloud, and additive manufacturing. I'll briefly talk about this, but believe me, this is only a tip of the iceberg. There are basic things which has to be done very well in terms of the product data management, the engineering of the process itself. These are traditional. Please don't forget, these are the must for all of us in terms of planning system, in the manufacturing process planning itself, in terms of the warehouse management. These are all the basics. We always talk about IoT today. We always talk about analytics. However, I strongly believe that we should be strong in our basics, in terms of production engineering, in terms of the machines, in terms of the tooling, in terms of the fixtures, in terms of the CAD/CAM, in terms of the manufacturing. This is a must. Normally, what happens is, I always feel that everybody talks about only this, higher end. But we as professors, we as guiding should make the base stronger. Okay, that's the most important thing in thing. Even in people coming to our factory, I always ensure that the base is made stronger. Because fundamental, what is engineering? Engineering is common sense. Are we able to manage our processes better? Are we able to manage our fixtures better? Are we able to know what is the function of this fixture? What is the function of the cutting speed? Then we can talk about all the other things. So it's very important that we build the base extremely stronger in our engineering factor. Okay. So, but when you talk about new things happening in industry, how to reduce the number of processes? We are working towards the digital in terms of the 3D printing, and many of the prototypes we're able to make now, not in the full production area, wherein additive manufacturing is a key, and we are able to bring in very complicated shapes, and we have got our own 3D printing machine, and I'm sure college will already have but this is the future. What's happening is, if we have 3D printing of polymer, we are working towards 3D printing of metal. And can we have a hybrid of metal and plastic? Because we need to have both strength and lightweighting. So the main thing happening in industry is towards going towards 3D printing. And many complicated parts inside our engines we're trying to make into 3D. Similarly, the fixtures, the templates, we're trying to reduce the number of operations and making it into 3D printing. This is a new area where I think all of our engineers should be aware of and should do more projects on this. Though it's a costly process, but if you combine many processes together, it will be effective. And as I mentioned, you can have a patent of how you can have hybrid between metal and plastic. One more thing happening in manufacturing industry is flexible electronics. Sensors in our fixtures, sensors in our machines, sensors in our product, sensors in tubes, sensors in tires, sensors in suspension. How to ensure that the data is given from the vehicle to the customer. So there's another thing happening in terms of the, and we are able to make complicated parts in many areas in terms of the processes, in terms of the product, a combination which will improve the cost reduction. Some of the examples like mentioned here, and many things are applicable to the automobile industry itself. So there is a change. They are talking about flexibility. They're talking about earlier about additive manufacturing. It's happening more faster, and a lot of new ideas are coming in. I have a lot of engineers who have got a lot of new points coming in. We make our own automobile guided vehicle. And I found a lot of new ideas come from the engineers in terms of the styling, in terms of the processes, and in terms of the automated guided vehicle called natural navigation. And a lot of new ideas come from the students. Second thing, in the EV manufacturing, a lot of things are happening in the micro drilling, grinding, super finishing aspects, coating of the components, laser beam in terms of our building of our batteries, and in terms of the nano technology, another big topic. If you have got some time, my suggestion for mechanical engineers to know about nanotechnology. We have got something like graphene, wherein we are able to have additives to painting, additives to processes to improve the durability of the process itself. So in terms of micro machining, grinding, super finishing, improvement, because we have to reduce the friction, we have to improve the durability, we have to increase the range of the EV products, because now today 120 kilometers is not enough for battery between charge. It should be 400 kilometers. The demand keeps on increasing. So to manufacture that, we need to have an improvement of the processes. And itself, I think the micro mechanical system itself is a big topic to discuss. Laser, there's a lot of big discussion in terms of the battery, in terms of the wire bonding, in terms of the laser welding of the terminals. So it's a very interesting topic for all of us. And we are working very closely on nanotechnology too, in terms of graphene, in terms of paint, in terms of many areas. And this is the area in which I feel young engineers can work with the industry to make new projects. Next is on the advances in the materials. There are a lot of new materials coming up into the manufacturing. Like organic in terms of the new process of polymeric process, combination of the processes, inorganic in terms of the many areas of nanoparticles, additives coming in. And India, I think definitely over the next 1 year, you can see a lot of changes in terms of the hybrids. Hybrid not only in the vehicle, in the process itself, a combination I mentioned about metal and plastic together in 3D printing, things happening. And in terms of micro machining, 3D printing, area in which a lot of new things happening in the aerospace industries. Carbon fiber. We are trying to work towards the jute fiber to improve the durability of the process, durability of the component. So additive of fiber, carbon fiber, jute fiber, hybrid areas, and many areas in terms of vacuum forming. And one area we are working is how to eliminate paint, how to eliminate welding. These are the areas, new thoughts coming in. So these are the areas we're talking about laser and trying to make the process easier. We can't find out whether it is assembled at all because all the combination on the 3D printing coming to picture. And improvement of process itself. So there are advances of materials, processes, and of course on the machines. Machines are making much more integrated machines now. And we as manufacturing engineers can design and develop new machines which is required by us. You work very closely with Toyota. And we learned a lot of things from them in terms of karakuri. How to ensure that we can have motion without power. How to have, suppose the door opens, can it open and activate the coolant tank? So we are trying to combine many areas and make it low cost, make it efficient and low cost. I'm very much listening on karakuri, and there's a very good, we have a very good discussion with Toyota team, and TVS and Toyota work very closely with environment and ergonomics, easy for the operator by this karakuri. In terms of automation, I think all of you know SCADA, and it has been a major requirement for all the process plant and the manufacturing automation. So all our areas, whether it is an AGV which we make, or cobot, where the robo works along with the operator, which will ensure that the ergonomics is better. If the heavy weight component is done using the cobot or the helping the operator, and everything is controlled. And these are all very simple today. All the SCADA controls are made by our engineers inside our factory, and all are linked, and there's no high tech at all, because it's all linked up from the machines to the fixtures to the component to the tooling, and in terms of the automation. We also strongly believe in definite low cost, because we can't survive if there is high cost of processes. AGVs which we make is at least 30% cheaper than what we get outside. Like that, it can be many examples in terms of automation. So over the period of time, there has been a change in terms of the customer satisfaction and agility, in terms of the growth, profitability. Earlier it was department layout, the process layout came into picture, the product layout came into picture, and now in TVS Motor we saw see-through, JIT in terms of the just-in-time. We went in for lean manufacturing. Today, what next? We are talking about integrated manufacturing. That is combination of all. I mentioned earlier, like the base should be stronger. Along with the base, we can have digital, we can have integrated, and in the next 4 to 5 years, definitely the digital integrated system will be the key for future. And value-driven products. And definitely you can't define the profit, we have to improve the value. Then only we'll be able to get the profit and the improvement in our process itself. And customer for life, how to have employee satisfaction, how to have customer satisfaction. So this is the changes happening in the Indian manufacturing industry. And if you talk to anyone in Toyota, if you talk to anyone in Volkswagen, they have a similar view in terms of the integrated manufacturing, which will help that we give products which is value add to the customer. Okay. So what will happen in the next 10 years? We'll have more change than the 50 years before. Definitely not even 5 years. So in terms of, I talked about manufacturing. Why it's important is the vehicles are becoming complex. So I'll go back to the design now. Okay. Little bit talk of design also, which is important. Why manufacturing has to change. So there's been a lot of integrated subsystem happening in the designs, in the product. Compact design. If you see our iQ vehicle, in terms of the EV vehicle, it is compact and very well durable compared to any other competition vehicle. In terms of end torque, a complex design in terms of electronics, charging of the vehicle, you can get your data system and everything on your vehicle itself. Next is analytical skills, because how to do it right the first time, how to have modeling, simulation before the actual build. Why? Because it reduces the lead time. How to have integrated control and plant simulations. And definitely we have multi-location, we have factories in UK, we have factories in Indonesia, we have taken over Norton. So many areas are multinational operations. But can we build our system? Can we build our Indian system and standardized modules in terms of the vehicle reuse, in terms of the process reuse? I always call it PQCDMEES. the productivity, quality, cost, delivery, morale of the people, energy, and environmental improvement. So, and safety. Linking of all the things are important for manufacturing. So the more important is the complex vehicle design will make our manufacturing tuned to the requirement and delivery of the designs. So I always believe in going to the basics. Okay, so I like to go to the basic a little bit. If you have manufacturing systems, normally you have machines, methods, parts handling, measurement system, right? Then we have to go to the next level of areas in terms of the fixtures, okay, tool holders, monitoring system. In TVS Motor, we go still further in terms of the machining areas, in terms of what type of fixtures, in terms of self-cleaning, self-adjustment. We have made a fixture, there is clampless fixture. There's no chip in the fixture itself, zero adjustment in the fixtures. How to have, these are all new ideas, nothing rocket science, it's an engineering idea. So focus on immediate customer. Who is the immediate customer? Operator is the immediate customer. So this is the area in which TVS is different from other companies. We go into the basics of everything and ensure that we give value added product to the customer. Okay, that's the difference. Okay, and in bringing and bring all the new things, bring big data analytics, autonomous robo, which you can make internally, simulation before the layout is put into practice, and of course AR VR for training of the operators. So all of you are welcome. TVS Motor, we can show some of these examples and bring in more of additive manufacturing. So I strongly believe that once the base is stronger, we bring all the new things into picture, you'll be able to sustain over a long period of time. Okay. So to make this happen, we call it as a roadmap. We call digital manufacturing as a roadmap. Now we have got AR, VR, in terms of augmented reality, training of the people, in terms of the welding, in terms of painting, and we have a roadmap over a period of time. We have got predictive maintenance, machine learning, and natural learning, networking in many areas. Okay. Similarly, in terms of the, we went from magnetic tape to natural navigation, automatic guided vehicles today. And these are the areas in which it's happening continuously in terms of automatic handling. One thing is important in manufacturing is logistics. Because of today's world of war and different areas, how to improve the logistics, how to reduce the cost of logistics, how to improve the material handling, how to have simulation of the layouts, inventory at different places. These are all mechanical factors. And all of us are working very closely to simulate the processes on logistics. So what are the changes in product requirement and what will change today? Definitely the hydrogen fuel cell is going to come in a big way over the next 10-15 years. Slowly, according to us, the IC engines will come down. However, electrical will pick up. Diesel is already in the area, and majority will be hybrid. Because finally, we have to reduce the consumption of power. So these are the areas in which we're all working, and this is available in the net itself. So it's all. Next is towards hydrogen fuel cell, battery in terms of the hybrid vehicle. In terms of the IC engines can come down, but definitely it will improve in terms of the hybrid, and it helps in the fuel efficiency of a vehicle. And over the period of time, I was told that hydrogen will be the major change in probably in the next 10 years, next 5 to 10 years. Already the vehicle already there in the field. So alternative fuel in terms of LPG, CNG, we have all the vehicles of LPG, CNG in a 3-wheeler, 2-wheeler, biodiesel in our vehicle, and EV. Next will be the hydrogen, probably in the terms of the fuel cell. Already Toyota has showcased Mira, their vehicle in fuel cell, and definitely slowly how you can get hydrogen by hydrolysis and ensure that you are able to get from water, and how we can make it much more fuel efficient, how to make the fuel cell more efficient. These changes are happening. So as a mechanical engineers, let us be aware that these are all changes happening, and let's be open to understand, learn, because many of these has to be developed and manufactured by the mechanical engineers. So I'm just trying to talk about mechatronics, which will improve mechanical and electronics together and combination of all the industries. So many things are happening in terms of the dynamics of the vehicle, control system, the overall view, transmission improvement, in terms of electrics, in terms of the thermal composition. So it is always multi-physics. Why I'm coming back to physics is, please don't forget the basics. Please don't forget the simulation. Please get back into business and what's happening. So even in your first semester thing which you learned will be applicable to the industry when you come to industry, if you know the application portion of it. So in terms of multi-physics simulation, in terms of the dynamics, things are changing. So engineering effort is very important. So in terms of the durability I talked about, how we can improve durability? The main thing in industry happening is lightweighting. We have thin wall components, dissimilar material, aluminum, titanium. How to reduce the weight by half? If you reduce the weight by half, the durability of the range increases. How to reduce the friction? Friction can be reduced only by reducing the tolerances. So can you reduce the tolerances? Can you improve the micro machining and finishing processes? And how to reduce the time? Can it be digital simulation before implementing? Integrate all the software tools. Software is only an enabler. Engineering is taught. So how to bring the enablers into action? So be open, and these are the road ahead in manufacturing. I just put it in 4 or 5 points. I think it's very important to know that whatever you're doing, can you reduce the weight by half? Can you reduce the lead time by half? These are the demand on us, on engineers, when we come into our factory. And definitely all of you will be a participant in making it happen. So in terms of mechatronics, I mentioned about sensors, application, working with cobot, robo, and data analytical tools, how we can apply these tools and advance the tool materials like honing, lapping, super finishing. I mentioned about this in my earlier talk, and how to make it first time right. So the top major thing is how you can get integrated view of all. Okay. So engineering, the new areas is sensors, simulation, data analytics, analytical tools in terms of the processes of battery controllers, all towards zero defect like manufacturing. I can talk about zero defect in a much more detailed area, how to build in, how to ensure robotics and automation, advanced in finishing processes. So the inputs required from the curriculum to the current one, to add all the things to make it for the future. Future meaning now, I'm not talking future, I'm talking today. So how to ensure that we are combining many things together in our syllabus and ensure that the engineers come out. So there is a paradigm shift in the manufacturing in terms of TQM, total quality management, total productivity management, Six Sigma, JET and TPS. But one thing is, don't be overwhelmed by the tools. Okay, keep the goal in mind, keep the objective in mind, and ensure that it is taken. Okay, and this is by Toyota, which says you always have to have respect for people, respect for process, respect for new change, and go into the basics before you're making new changes. Understand the basics strongly. So these are the emerging areas in terms of the robotics, in terms of 3D, AR, VR, I mentioned, and then the new age technology of connected processes. Hence, there's a new role for engineers. The name of the engineers are changing in terms of AR, additive manufacturing, augmented reality. So what we're trying to do is Industry 4.0 is driving it. And today, all are combined together, electronics and communications, computer. So please don't think I'm only a mechanical engineer. And it has to be a combination of all the things. Okay, so it is going to be multidisciplinary, interactive, interdiscipline going to happen. Okay, so it's already happening, and you be aware of it. And it's all common sense. So easily can be applied. And in terms of the product life cycle, with digitalization, connected machines, distributed data analytics, traceability in terms of the machines are concerned, predictive analytics in our area, how to improve the quality, speed, flexibility in each area. So what we do is in a new product development, we have product design, the production planning, production engineering, production execution services. We divide, I've got a detailed chart in which what each group are doing, what is happening new, and what are the changes is going to happen further. Like what I mentioned earlier now is there, we can talk about it later. So what's happening in terms of mechanical industry? There's a demand for a lot of interaction in design development. I mentioned about lead time, research happening in terms of the new material, new processes, and academics are also working together with us to work along with our automation in terms of the improvement in nanotechnology. So for the growth of competitiveness in India, we have to work all together in terms of industry, academics, and research. And TVS is very, very particular that we work very closely with research and very closely with academics. There are a lot of new roles coming in. I'll skip directly in terms of the factory automation engineer is a new topic. Digital manufacturing engineer will be the new role. Digital quality engineer is a new role. And additive manufacturing engineer is another new role. Data analytics. So the methods engineer is changing to different areas. So we should be prepared that we are working very closely in terms of the automation, which I talked about, in terms of details, which I talked about, and each one can be a lot of questions where we can work together. So, and there are a lot of new things coming in academia. Syllabus includes specific topics. It's all must be happening very much, but we are very keen to support from the industry. Can we have more internship? We are all welcome to TVS Motor in your different semesters. You can always come to a factory to understand what we're doing, and specifically to whichever area you want to go detail into it. So last few years, we're working with industry, with the institution in supporting, talking about giving lectures on agile, flexible manufacturing, TQM, TPM in practice, actual practice, cost of poor quality, improvement on automation, supply chain management. These are the areas where design thinking, where you can bring in a lot of improvement in your syllabus. And we also work in terms of Nachimutu and other areas, faculty development. We have supported in simulated lab and in terms of the on-job training in the factory, in the colleges. See, we take 12th standard students and then help in diploma and Nachimutu and Tyagarajar colleges in many areas in Tamil Nadu. And of course, we're working with RV and other colleges too, in terms of the curriculum changes and needed for our business. So, and most important thing, as part of our industry, as part of institution, we can work with all. I think Dayan Sagar must be working with all the institutions because we are all customers for them. We are customers for Siemens, Fanuc. So we tell them, Siemens, you should work along with the institution more, colleges more, create a center of excellence in many colleges. And it's already happening now. Festo, so that when they come to our factory, when we are using all the things in our factory, they can do a much better job of understanding. So this is the reason why I work very closely with all the suppliers and ensure that interact with the institution, with the colleges. They set up their own center of excellence, and I think it's already there, and it can be extended still further. Bosch, Festo, I'm sure you must be already having this, and ABB, KUKA, Zeiss, all these things are fantastic. My suggestion is at least 4 or 5 industrial visits specific to all these industries will make a lot of difference for the engineers when they come into the factory. And bring it to simulated sector. They can take a lot of projects with them. How to avoid destructive testing is a new area. Can we test the weld strength without destructive testing? Is a new point. How to bring in 3D printing more and more in our area. Cryogenic processes. Okay, so these are some of the examples. I think I'll share this with you. These are all some of the examples where definitely a lot of applications are possible in our area. And definitely we work very closely with the faculty, and especially from in terms of NITI, in terms of the even IIM Bangalore, people have a lot of faculty come to our factory to understand. We share new ideas, we do. And it is not for any not that industry we know everything, because we depend upon institutions, we depend upon education institutions to bring in new ideas. A lot of new case studies can be taken. So I'll go quickly. So main thing in this today, all of us, is a VUCA world in terms of the complexity, what we are having, multi-decision factors, very daily the thing changes. How volatile are things happening, and rapid and unexpected challenges are happening. Of course, we have ambiguity, unknowns, many things are unknown and uncertain. This is a different way of looking into VUCA, right? So this is probably in terms of the threat to the manufacturing industry, threat to the automobile industry. So I try to take it in a different way and make it positive. In terms of, are we ready in terms of the instead of volatility? In our factory, we are going to have a big vision to succeed in this area, to bring in new products, value-added product. Can you bring into value-added product into our area? In terms of uncertainty, we are trying to understand the customer. And can we untap the potential of our engineers? We are working very closely in terms of this. And though it's uncertain, can we tap the potential of the people? They're fantastic people by the nature. In terms of complexity, can we bring in clarity in our area? How? By going towards customer focus. Go to the customer. I talked about in the internal customer, you're talking about external customer. How we are able to overcome the complexity by having clarity and customer focus. And in terms of the ambiguity, go towards agility, flexibility from the beginning, and can be action-oriented and digital. So future is not mechanical engineering or electronic engineering or integrated engineering. Is going to be customer-focused engineering and innovation. Innovation is a continuous journey, and everything, what I'm talking today can change tomorrow. Things are changing in terms of the world. So all of us should be ready to ensure that we are in a very fantastic situation where we can give the best to the industry and bring in the best to the institution. And thank you very much for the time. And I'm sure that I had 1 hour in my mind. I'm able to cover the overview of the thing which I want to. And now I'm open to questions, please.
Yeah. So yeah, I'll ask students to raise your questions through a chat box. That would be preferable.
Yeah.
So there is one question. Yeah. I'll be the moderator. Yeah. Ramesh Kupas. One of the best speech, especially for youngsters. He is appreciating the talks. Yeah, really great. Yeah, it is very informative and very required, very much required for our students. Yeah, please raise your questions. Hello.
Sir,
I have given you the overview.
Yeah, while the students have a few questions, I just had only one personal question, sir, based on your experience. This electric vehicle thing is catching up very fast.
Yeah.
When do you think these petrol pumps and other things will get replaced in the next 3 years, 5 years with some refillable battery chargers? What's your take on that, sir? I'm just curious because
see what's happening is the most important for all customers like us would be the range, would be the cost, and in terms of the maintenance of this vehicle after 2 years and 3 years. So now it's picking up in terms of the benefit that the government is offering. Government is saying, okay, if you're buying an electrical vehicle, we will ensure that some portion of the money will be given by the government, and hence the cost becoming competitive. Till the cost becomes competitive for all of us, there'll be a big challenge in terms of the thing. So probably it's catching up very well. And I think as a personal front, I always believe that let us take the overall environmental benefit of it. If you take the origin of the battery, how it is efficiency to manufacture the battery, and compared to the oil which is going to be there or petrol going to be there, I think it's going to be. I think it will be a combination of these things now. Though it will take some time, it is changing. People are really happy about the vehicle which you are having, but still, it will take some more time because India is a big country. We have rural population. We have a huge this thing. So how it spreads to the local market, the range in which I need 200 kilometers on the vehicle, right? If you want to go somewhere else. So technology has to develop to bring it happen. So probably I feel hybrid can be one area where it can, instead of charging going out, it's self-charging as you drive the vehicle. Can be one step before, and probably local market going to the metro and all, maybe EV may be better in terms of very small area. And slowly, I think government also is putting a lot of effort. We are also putting a lot of effort to improve the range of our vehicle, and of course, how to bring the cost down. Cost can come down only when you start making the cells yourself. When you make your battery yourself, suppose you are importing, and I think they always goes by the cost of the import itself. So it is a good journey. I think it will take some more time to perpetuate across. IC will continue for a longer time because of easiness and flexibility portion of it. And the government also cannot extend all their this thing always. So I think we as manufacturers should bring the cost down. Take the benefit of PLI to manufacture here many things. I think PLI is a big subject. I don't know whether Dan Sagar is talking about the PLI schemes, methods, how it is helping. I think we should talk more.
Yes, sir.
So please have that in one of the topics to discuss. And it's a very interesting scheme by itself, and how it can be applied. And it's all thoughts. So, if to answer your question, Arvind, is
bottom line is cost margin.
Yeah. Finally, as a customer, we should be able to get the product of my value add to me, and ensure that
I think others are too. There's so many questions there. I'll probably request.
Yeah, sir. I'll moderate, sir. I'll go.
Thank you, sir. Thank you, sir.
Yeah, thanks. Yeah, this is from Mr. Ravitej. How cryo-engineering helps in automobiles growth?
Yeah. So cryo-engineering we are trying to use for the improvement of the tool life and heat treatment. Tool life is another area where we are trying to improve, because cost per component manufacturing, how to reduce the cost per component. So if you increase the tool life, we are able to see some of our carbide tools and some of the tools, we are able to increase the life of the tool, and hence the reduction of the cost per component. That's one portion of it. Second thing is in terms of the pressing of the bearing, because now the friction has to reduce. So we are trying to chill the component and then press the bearing. Similarly, a cylinder sleeve, where we have chilling of the component and pressing the bearing itself for the cylinder sleeve. So these are the processes which will improve the friction reduction. Tool life is one. Friction reduction is one. Third is the properties of material. Cryogenic heat treatment is another area where we are working closely, but it is still quite challenged in terms of liquid nitrogen, getting the liquid nitrogen. And I agree with what question is asking in terms of the embrittlement. See, what we try to do is there are some post processes required after the cryogenic treatment. We need to have tempering is required after post processing. Similarly, we can't be doing cryogenic treatment on the heat treated part. So we may have to have a combination of which is the best process and link to that this thing. Okay. So but it is very important now in terms of the process itself to try out new things. See, we are trying to work in terms of with again a research work, trying to work towards aluminum and steel together in a product. Hybrid in terms of the weight reduction because of aluminum and durability improvement because of the steel. We are trying, but you can't weld together. We are trying to do riveting and then welding. So many processes we are working with Warwick University on the improvement of processes, which will improve this type of requirement on lightweighting to our vehicle. I hope I've.
There is one more question.
One more question. NDT.
Yeah. There is one more question, sir.
Yeah, please.
Sir, you talked about jute fibers. Can you elaborate which components are manufactured using these fibers?
No, it's still on the research work going on. We are trying to make the component, like for example, covers. We are trying to make with jute and polymer to make it lightweighting, to make the clutch cover in our vehicle, to make it aluminum and jute. It's a very interesting research work we are doing along with Nano Technology, and it's still under trials and still under the thing. But I feel this carbon fiber, jute fiber will pick up in terms of the lightweighting of a vehicle. So we are saying, but not in a very structural part. Okay, we're trying to work towards covers. We're trying towards the side covers in the plastic component, engine shield area, another one which are trying to work. So we are going towards surrounding parts, not structural part initially. Later on, we will try to have additive in terms of carbon fiber to improve the durability of it. That's another in terms of carbon fiber. Jute fiber, we are only for the cover parts we are working on.
Thank you, sir. And we have one more question from Ramesh Kuppuswamy. There is a shift from a top-down approach of manufacturing to the bottom-up in manufacturing approach in manufacturing. What is the role of secondary manufacturing processes?
Okay. See, manufacturing is a combination of both top-down and bottom-up. The policy, the strategy, the thinking normally comes from the top-down in terms of the strategy requirement, and bottom-up. See, we have a scheme called suggestion scheme by the operators. Each operator gives something like 60 to 70 suggestions inside that place of work and implements in the factory. Okay, that suggestion scheme coming from the bottom up. Similarly, now what's happening? This suggestion scheme has gone to his hometown, to his family. We have something like in our factory, we have a family day where we have Founders Day, where the new ideas, fantastic new ideas comes in the family. How to serve, how to conserve energy, how to have fires inside the house, how to have electrical alarm system for the children, like that. Small children in their family, we are trying to imbibe the suggestion scheme which are trained in the operators in the factory. They're taking to the family, and we get so many. They present these in many international events. The family of the we give them the benefit awards. We have to ensure that they are contributing very well. We call in front of the entire factory and we give them award to the families. Now it has gone to the community. We have got TBS community system inside our schools, inside our community for the road services, temples. This type of manufacturing system movement happening from the factory to the family's house, to the community, to the thing, it's outstanding. And if you can, I'll share some of the examples in COVID times. You can't believe that this type of thing are happening by the engineers themselves, by the operators themselves. So this manufacturing is not only in the factory, it spreads across to the community, to the entire this thing, and really outstanding. Some of the case studies and examples are so good in terms of the power saving, water, very, very small thing. Water saving. Now we have got themes now in a factory. This theme towards the energy saving. Last time towards the COVID in terms of how to take the safety of the people, safety of our own locality, cleanliness of our own locality. So it has gone to applying this manufacturing systems approach to the family, to the community, to the entire thing as a whole. So it's you should see to believe that this is the power of engineers. This is the power in which we should tap. That's why I said potential of our people. We should tap and get the best out of people. I hope I've just answered that question a little bit in a different way.
Yeah, next question is slightly like some statutory kind of a thing. So government is also supporting sugar industries for production of ethanol, and there might be chances that ethanol will be used with the petrol as well.
Yes.
What is your view on this? Yeah.
Yes,
Yeah,
we already have.
Of course, we are using it.
We already have ethanol in our this thing. We see, like India, no, Brazil is a big country. Like
20%.
Okay, Brazil is a maximum sugar producing, and in that we are supplying our Apache, our vehicle to Brazil, which we can work on 100% biofuel. 100%. So what they do in that country, I've been to the country during the month end, everybody changes to ethanol because the price of ethanol is 1/10 of the price of petrol. So they shift. When they fill the petrol, they fill only ethanol. So, but the vehicle should be able to run. So it's called flexi fuel policy. And now Gadkari is pushing that in India also. He says we can reduce the buying in of fuel, and slowly it can improve from 10% to 12% to 14%. See what happens if you use ethanol in our components is, it rusts. We have to see the bearing, we have to see the oil seals, because its water content is higher. So we have to ensure that the component, like the improvement of materials, which I talked about, improvement of coating, which I talked about, improvement of processes, has to improve to take care of the biofuel or bioethanol base. And it is definitely going to happen, and already happening in India to 5 to 6%, and probably it will be 12%. And may not be like Brazil, which is flexi 100%. We are in line, and we have got all our products today which can take a biofuel, which can take flexi fuel, we can take ethanol. We are all ready to make it happen.
Thanks, sir. And
you can see it very closely in India, very close, very quickly in India. Yeah.
What could
and
be
India is so fast. India is so fast because I thought about BS4 to BS6. We skipped BS5 in India. Only country who can skip BS5 is India, and is only because of the government. Because of so much of importance for environment, so much of importance to the energy efficiency of our vehicles, so much importance to the customer, and probably because of Delhi, I don't know, maybe because of many areas, how to bring in the, we skipped from BS4 to BS6, now new regulations is coming. India is going very, I'm telling this for the students, India is going very fast pace in terms of regulations, in terms of safety. You've got ABS in all our vehicles. Never we thought that ABS in 5-10 years back to come into all our vehicles about 125cc. To improve the safety of the thing. Insurance has changed, it is improved. And combined braking system to improve the customer. So it is all outstanding time period. Why I'm telling this, for the engineers who are coming in probably next 2 years, industry is going up. We should be in a pace in which we take up the best and be in that league for development of the country.
Yeah. There are a few more questions, sir. It is, I think you have answered it. Cryogenic introduces embrittlement of work materials. How will you address that? You have told it already.
Yeah, absolutely.
Yeah. Hello, sir. My question is NDT. NDT is used to development of mass market product. And how important NDT is a non-destructive testing, and how important is it?
Yeah. Okay. I think you touched a very big topic which I'm working very closely. See, one thing is, for example, I'll take one example of the welding of frame. Okay. Today, to check the weld fusion, we cut the component. As samples, we cut, check the penetration level, take the white body of it, check how much is the fusion, and talk about whether the welding is okay or not, and improve the joint so that we improve the welding. So, but can we do it continuously? Over the period of time, we are talking about NDT as a checkpoint. We are able to do NDT of a crack detection in our area. Okay, cylinder block crack detection, we are able to do non-destructive testing. Now we are working towards in terms of the welding areas where we have thermal images sent, and we are able to see the depth of the weld. Still under research work going on. Similarly, we are talking about non-destructive testing of the paint film. paint, you know, paint, we apply 100 microns of paint in a component. How do you know that you have applied 100 microns? What is the thickness where we measure? So we have now thermal. In fact, there's one, yesterday I was working along with the this in Netherlands, who has got the oxidation, the thermal check whether the depth of the wet paint is 100 microns or 200 microns. We are working very closely on it. And NDT will come into a big picture now in terms of the measurement. Now laser is coming to picture of measurement. Now we have left a lot of gauges and got for laser machining, laser checking, laser inspection. Similarly, NDT for on-district testing of our welding, painting, joining processes is coming up. I think German is leading in it. We had a lot of good discussion with the German team, and it is definitely catching up in all the aerospace industries today, because we can't cut any component to check the penetration level. Whatever is happening in any other industry, whether it is chemical industry or petrochemical industry or aeronautical industry, believe me, comes to automobile industry.
Yeah.
So we have to definitely learn from different industries and work and doing it. And NDT is coming in a big way. And if anyone is interested in doing research on it, it'll be very, very interesting to do.
Yeah. And even sir, our department has organized 2 lecture series on NDT.
Yeah. Fantastic.
Yeah, Dr. Vijendra Bunikoti, he is a consultant from Germany, delivered the talk. Yeah. Yesterday,
you can ask him more questions. You can ask him more questions on this.
He was, he was there with us yesterday also. Like he is visiting India at present. Tomorrow he is leaving for Germany. And we had a discussion with him also. Like we, in fact, even some students were called, and we had an interactive session also with the students.
Then you should do some projects with him in terms of the welding penetration level, thickness level. He can do,
Yes, sir. Yes, sir. Definitely.
Okay.
And this is a lot of questions are there. This is Ramesh from Ataria. Can you give opportunity to implement intelligent grinding system? A lot of questions. Insist.
Can you share with me?
I think that would be better. Yeah, I'll share your
one more day only on question answering. We'll have discussion on it.
Yeah.
Okay, no problem. I need to leave because 12:30 is another meeting is there.
So thank you, sir, for a very wonderful talk. You touched upon complete current industry scenario, where our manufacturing industry, manufacturing scenario is standing, and where how to adopt ourselves, academia also, how to integrate these changes with the academia so that we can make or we can train our students to the current industry requirement. Thank you, sir. Thanks a lot for your valuable time. And
I always believe that,
and I would like to thank you for inviting us. Yes, please go ahead, sir.
No, I always
for inviting us to
I always believe that students are for future, and they can bring the best to the table. And whenever whatever semester they're working today, if they know the overall picture of what's happening and try to apply their practices, strengthen their base and apply their practices, it will be the best engineers where we can get for our industry. Because it's win-win for both. We also should get best engineers to our country. It's win-win for both. So more we share with you, more we get interaction with your students, more benefit the industry will become.
Yeah, thank you, sir. Thanks a lot, sir. Thanks a lot.
Thank you very much. Thank you, Arvind. Thank you, everyone. And I hope it was useful.
Yes,
and thank you very much.
Definitely.
I take leave.
We'll come back to you, sir. I'll reach you, sir.
Thank you. Thank you.
Yes, sir. Thanks. Thank you, Imtiaz, sir. Imtiaz ji, thank you.